question. Today is 2nd of February 2023 and the question is 953 verifying an alien dictionary. So in an alien dictionary, surprisingly, they also use English lowercase letters, but possibly in a different order. The order of the alphabet is some permutation of lowercase letters. Given a sequence of words written in the alien language and the order of the alphabet, return true if and only if the given words are sorted lexicographically in alien's language. So let's start with the basics. The lexicographical order means the normal order of the words in our normal alphabets in which they are sorted in an increasing order. So they are given a order of letters which is an alien order, and we have to just find if the words given in the words list are sorted according to that order in the lexicographical ordering. So for this question, we are just using a naive approach, the basic approach, because we can see the constraints are not that much big. The words length will be 100, and words of I that means each word will be less than equal to 20. So let's do this. So first of all, let me zoom this in. Hope that this is visible on every kind of screen. So let's start. First of all, what we are doing, we are just taking the order. Let's take one example here. So this is the example. Suppose we are taking this one example and then this apple example. Okay, let's write all the examples here so that it can be easier for us to see. So first one will be true, and all the second and third both will be false. So let's start. First of all, we have this order and it's guaranteed to be of length 26. So we will just map this order using a vector. So let's start. Vector of int, and we'll call it as position, and position will be a 26 length. For int I equal to 0, I less than n, I plus plus. What I'm going to do is I'm just adding position of order of I minus a equal to I. So what I have just did is I just took the position vector, and in that position vector for each order's ith element I subtracted a from it so that it will be mapped to index 0 to 26. So how this is working is just like this. If I have a, then a is 65. Sorry, it's not 65, it's 97. A is 97, and I'm subtracting a from it. So minus a, which is also 97. So 97 minus 97, which is equal to 0, and therefore a minus a equal to 0. So in this way this is working. Hope you got it. Now I have to change this to order dot size. Okay, after that, as we have mapped all our indices, now we just have to traverse over the words list and the words and do our business logic up there. So first of all, we are checking if it's not sorted. If it's sorted, we are going to return true. So for this condition, I'll just return true at the end of the function. So if our business logic worked and gave output as false, then the string or the word list is not sorted, and if it does not give answer as false, then it is sorted. So what we are doing for this is we are just traversing over the words list. So this is the words list. So let's go for int I equal to 0, I less than n, I plus plus. Okay, first and foremost, we have to check every two elements. So suppose we have this particular array. So what we are going to do, we are checking this element with this element if they are in order. If they are in order, we just keep it. Now after that, we increment I, so I will become 1, and we check this element with I plus 1, that is this element. But after checking this, we get answer and all that thing. But if I comes over here, that means I equal to 2, then we don't have I plus 1, that is 3, and we will get an error. So to remove that error, we are just traversing for index I till this index only. That means till index n will be here. Here will be n index which is not available. This is n minus 1 index. So we are traversing till n minus 1 index, means we are traversing only this part. I hope this is clear now. So we are traversing over this. Now what we want to do is we want to traverse over the characters of each word. So it will be like for in j equal to 0, j less than something, and j plus plus. Okay. Now j less than will be what? So suppose we have this word and this word. So if I can traverse over this, then I have access to the first four parts of this word. And it is given that if we have something like this, then the lexicographical order will be app and then apple. Therefore, if the first word is small or large, it does not matter. If it's small, then it must be lesser. If it's large, then we will do something else. So therefore, we will just traverse for words of I dot size. And here this n will be nothing but words dot size. Okay. Now, as I said, if we are traversing and we got a number, we got the word uh, which has characters equal to the next word, then we are just keeping it. Okay, so if we have to use the position array here, so we have three conditions: if the word is less than, if the word is greater than, or if the word is equal to. Okay, so if the word is, if I is less than I plus 1, then we are doing something. If I is greater than I plus 1, then we are doing something. And if I is equal to I plus 1, then we are doing something. But what, according to this problem we are framing, is if our I is less than I plus 1, that means position of letter at ith index is less, then we are just going to break, because we found a letter, we found a letter in a word which is lesser than the given letter. So all other letters after that does not matter to us. Okay, suppose we have this thing, we have hello and LeetCode. So as you can see here, H is coming before L. So if I found H and then I found L in the next word, then this order does not matter to us. We don't care about that order because we found the first letter which is lesser than, and it's in the first place rather than being the second place, so we can just break it. So let's write a code for this. So if position of words of I and jth character minus a, according to this particular rule, minus j is less than position of words of I plus 1 j minus a, then we are just going to break. Now the second condition, so here we are breaking, so we don't need else if, we can just use if. So therefore if I will just copy this, it's the same thing, just the sign is changed. So if the current word, that means ith word, suppose here, if the ith word and this word, so the w is coming before r, w o r, w o r, and the difference is d and l. So l is here and d is here, so these are not sorted. According to rule, the word must come before a word. So we traversed over the string, we compared this till this, so WR is the same. Now we found D and we found L. So what we want to do is the L must be before D, but it's not before D. Therefore, the position of words of IJ, that means this D, is greater than position of words of I plus 1J, that means this L, and it's true. And as it's true, they are not sorted, and as they are not sorted, we can just return false. Okay, if they are equal, if the words are equal, then we can just go on and continue our loop, because they are equal and so we don't have anything to update up there. Okay, so do not do anything. Now the cream part of this problem, If we are not doing anything and words are equal, suppose here we are not doing anything and app this will travel till this and this will travel till this, but this is a larger and this is smaller. So app, I'll write here apple has length of 5 and app has length of 3. Okay, so apple will travel like this. First I will be here, AA equal, it will skip. Then PP equal, it will skip. Then here, PP equal, it will skip. Then it will go here and it will see that I am J and I am less than or equal to the length of my next word, which is equal to me. So up till this point, these two are equal. And at this point, we don't have anything to compare. As we don't have anything to compare and the ith word is greater than I plus 1th word, then it's not sorted because they must be in order of this app and then apple. But they are in order of apple and app. So they are not sorted. Therefore, this is a condition. If j is greater than or equal to words of I plus 1 dot size. If they are equal, they are greater than or equal, then I'll just return false. And hopefully this will work. Let's see. Yes, it's working fine. It's working pretty fine. Let me zoom it out so that it will be visible. Yeah. Okay, so it's working. Let's submit it. So it's 65% faster. Previously when I ran it, it was about 90% faster. Let's see again. It's 72% faster. Okay, let it be. So this was the solution. I hope you understood the solution. If you understood the solution, subscribe to this channel, like this video, share this video with all your friends who are stacking up in this problem and can't complete their LeetCode streak. Thank you very much. I'll see you in the next one.